Okay, coming to this program, and 8000 you have the data, the count value, and 8001 onwards you have the data. Initialize 8000 to DS register and 1000 to SA register. Bring the first byte, because DL register is destination. Of course, that is 8-bit register. Yeah, you have brought array size to the DL register, and DL register is being decremented. Why? Because array sizes, number of iteration and compare and all, starting from array size minus 1 time, right? That is what it is being decremented, right? Then the DL content is being copied to, here it is reversed, right? And the CL is copied from DL. Correct, good. Actually, this instruction not required, but anyway, this instruction is not required because already you have the instruction. Yeah, thank you. So number of iterations, CL DL register for number of CL for number of compare, and DL for number of iteration. DL for number of iteration, CL for number of compare. Okay, right. So when you start with the CL register and DL registers are same, array minus 1 time, because number of iteration and number of compare and all same in the first iteration. Correct? Yeah, good. Now 1001 data is copied to, 1001 is initialized to SI, and the data is copied to AL. And you are going to compare the AL content, which is already coming from 1001, with the 1002. 1002, right? SI is 1001, and of course this is 1002. And first data, second data being compared. If they compare, if there is no carry, then you have to exchange it. If there is a carry, you can skip the exchange. It is quite straightforward. Suppose there is carry present, it comes and it skips these two instructions. So otherwise, if no carry, then these two instructions are executed, then it proceeds further. Assume that you have no carry. Yeah, it comes here. It exchange AL content to SI, but SI content is not updated, right? That is what, again you are copying AL content to the SI. I think you have understand, right? And you are exchanging this and this. Yeah, the exchange originally happens, register to SI plus 1 and SI to the register. So originally what happened, the exchange happened on external memory. That is what these two instructions, right? Here clearly understand, you understand that this exchange happens internal register to the external memory. But originally the exchange should happen between memory to memory, right? 1001 content and 1002 content has to be exchanged. Now AL content, this is being exchanged, then AL and SI being exchanged is clearly saying that SI1 and SI contents are exchanged. I think you have understood. If you don't understand, you can talk to teacher and you can get the doubt is cleared. And once you have done, then you can increment for SI and decrement CL, because one compare is over. Then jump on no zero. Upon this comparison, you are checking for whether it is not zero. If there is no zero, then still more compare to be done. So go to the compare again. Yeah, SI is being already incremented. Now SI is 1002 and 1003 being compared, so on and so forth. That happens till getting 0. Once 0, it comes saying that all comparison and first iteration is over. Then you have to compare is over, right? Then CL becomes 0. Then you come here, then decrement DL. First iteration is over, decrement DL. It again jump on no 0 for DL and go to this one. So now it is n-1, right? n-1 is going for CL. Count register is being modified. n-2 now. Correct? Yes. Earlier DL and CL also both are n-1, n-1. Now every time CL, every compare CL is being decremented, and once it gets 0, then DL is being decremented by 1. Now DL is n-1, n-2. Now n-2 is copied to, array minus 2 is copied to CL. Again you are doing the same thing. I think this is more clear. If you don't understand, you can take a paper and write it in a paper one by one. You can work it out this instruction manually rather than typing in your computer and running it in Amazon. You work it out manually and be comfortable with this instruction. So, and coming to the post-lab questions, once you arrange it in ascending order or descending order, you can pick the maximum minimum value simply, nothing. And if I ask you for find out minimum in a given array, you find out the first 5 numbers of the lowest 5 numbers, or the first 5 greatest numbers among the given array. I mean bigger number in the given array and all. You can simply pick it from the numbers once you do the things in the arranging. The arranging the data. That's it. Very simple, the logic. And coming to this, right, develop an ASM for 86 sorting of 32-bit data in array size. Here not 32-bit data. Here 16-bit data you can try. 16-bit data and array numbers. Of course, if you try for 32-bit, it is fine too. And finding average of an array of numbers, find the maximum of a given array of numbers, LCM GCD. So these programs and all you can refer it in any others source book and all you can find out. You can refer any other source, the internet and books and all. Refer it and be clear in the logic first. Then you can type the code as such and you can get the result to be done. Thank you.